Let's see this question. This question came in GATE 2016 for 2 marks. Okay. The question is, let A1, A2, A3, A4 be 4 matrices of dimensions. These dimensions are given. The minimum number of scalar multiplications required to find the product A1, A2, A3, A4 using basic matrix multiplication method is what? So we have to find the product A1 into A2 into A3 into A4. This product we have to find using basic matrix multiplication method. And we have to find what is the minimum number of scalar multiplications. Okay. So this is a standard problem. This problem is what? Matrix chain multiplication, and this matrix chain multiplication is a standard problem in dynamic programming paradigm. Okay. So let's solve this. These are the 4 matrices given: A1, A2, A3, A4. Okay, and what are the dimensions? A1, the dimension is 10 cross 5, A2 is 5 cross 20, and A3 is 20 cross 10, and A4 is 10 cross 5. Okay, so in what order it has to be multiplied such that the number of scalar multiplication is minimum. Okay, so we generally solve this using dynamic programming, where we have a sub problem, and based on that sub problem we try to find a bigger problem. We try to find the number of scalar multiplications with respect to the bigger problems. What I mean to say is that if I say AI to AJ, it means that from AI to AJ all the matrices have to be multiplied, and whatever is the whatever is the multiplication happening, the number of scalar multiplications, let's assume that to be Mij, where we will create a table where at I comma j index we will put the scalar number of scalar multiplications required to minimum number of scalar multiplications required to find the product AI to AJ, which means something like, if somebody says A2 A4, then M2 comma 4 will have A2 into A3 into A4, this product, and this is a sub problem. So which I mean to say is that if somebody says A1 to A4, then this is a bigger problem and this is a smaller sub problem, right? So what I mean to say is that we will create a table. Okay, we'll create a table okay, and it will be something like this. And let's name the rows and columns 1 2 3 4 1 2 3 4. So each cell in this represents something like this. So M24, when I'm talking about, then this is basically in this table 2 4 I'm talking about 2 4. So this is going to be this one 2 4. When I'm talking about M14, then it is this cell. Okay, so the cells in the bottom are smaller subproblems, and the cell in the bigger one is the bigger cell at the higher level is the bigger subproblem. Okay, I have to find this one, isn't it? So for the entire multiplication from 1 to 4, this M I comma j here will be 1 comma 4. So here M14, this I have to find out, but this is the most biggest subproblem, and this has to be found out using dynamic programming paradigm using smaller subproblems. Okay, I will come to that how we will find out, but firstly let's start with the most trivial cases. If I have to fill this cell, then what is this going to be? M11, which means there is only one matrix A1, and there is no multiplication is happening. So number of scalar multiplications is basically 0. So m11 will be 0, m22 will be 0, m33 will be 0, and m44 will be 0. Okay. Now let's come back to m12. So when I'm saying m12, it means I have to multiply a1 into a2. So how many scalar multiplications will be happening here? Here there is only one way, unique way. We have to multiply a1 by a2. So we are multiplying a matrix of dimensions 10 cross 5 to a matrix with a dimension 5 cross 20. So the number of scalar multiplications will be 10 into 5 into 20. 10 into 5 into 20, which will be 1000. Okay. What about 2, 3? When I multiply a2 into a3, it will be 5 into 20 into 10. These many scalar multiplication operations will be done. So this is again 100 into 10, which is 1000. Okay. What about 3, m3, 4? We have to multiply matrices 3, a3 and a4, which will be total number of operations will be, we are just counting total number of scalar multiplications. Okay. So there is a unique way, and that will count as 20 into 10 into 5. So it is 15 into 20, which is again 1000. Okay. So we have come to this level. Now let's talk about m13. Okay. So when we are talking about m13, it means that a1 into a2 into a3, that is the multiplication we are trying to find, and that in that multiplication, whatever is the minimum number of scalar multiplications is happening, that we are going to put in that cell. Okay, that will be our answer for that cell. Okay, so when I'm talking about something like m13, it is basically a1 into a2 into a3. Okay, but in what order it should be multiplied? It can be multiplied in many ways, right? It can be done something like a1, and then firstly a2 a3 is multiplied, and then whatever is the result, that is multiplied with a1. That is one way. Another way is what? Another way is a1 into a2. We multiply this, and then the resultant matrix is multiplied with a3. This is another way, right? Okay. And so there are two ways, and whatever way gives us the minimum number of scalar multiplications, that will be filled here. Okay, let's talk about this. So in a2 a3, this sub problem is already solved. See, a2 3. So m2 comma 3, this is 1000. This is going to give us the number of scalar multiplications already for this. So we don't need to solve this problem again. We already know that just for a1 there is no need. So a1 is basically a1 comma 1. This is 0. a2 a3, this is 1000. But once we have these two matrices, one this matrix and the resultant matrix of a2 into a3, these two matrices have to be multiplied. And what will be the number of scalar multiplications for that? That will be, so what is the dimension of a1? a1 is basically 10 into, so a1 is basically 10 cross 5, and a2 a3. a2 a3, see, a2 a3, when it will multiplied, then the resultant matrix will have the dimensions 5 cross 10. 5 cross 10. So these two matrices have to be multiplied, and number of operations will be in that case 10 into 5 into 10. Okay, so this is going to be 100 into 5, 500, and 1000, which is going to be 1500. So 1500 scalar multiplications will be needed for this operation, for this multiplication a1 into a2 into a3 in this way. Now let's come back to another way. Firstly, if we multiply a1 into a2, then we already know that this sub problem is already solved. a1 a2, this is already 1000, we know, so it will be 1000. a3 is just a single matrix, so there will be no more scalar multiplications. But what about when we have this resultant matrix a1 into a2, its dimension will be 10 cross 20. This resultant matrix and a1 into a2, whatever we will get, its dimension will be 10 cross 20, and a3 dimension is 20 cross 10, right? 20 cross 10. So when we are multiplying these two, this resultant matrix with a3, then the total number of operations needed will be 10 into 20 into 10, okay, which is going to be 2000 plus 1000, which is going to be 3000, okay, and we have to find the minimum of these two, which is 1500. So 1500 is the answer for M1 comma 3, M1 comma 3. So A1 into A2 into A3, this value is going to be 1500, okay, 1500. Now in the same way, in fact exactly the same way, we are going to find A2 A4, which means that we have to find the number of scalar multiplications for the matrix multiplication A2 into A3 into A4, okay. So A2 into A3 into A4, as we did for A1 into A3, here also it can be done in two ways, right? So A2 into A3 into A4, this we are talking about, right? So M24 we are talking about, this cell. This also can be done in two ways. See, one way is A2 and we firstly multiply A3 A4, right? Another way is we firstly multiply A2 into A3, and then whatever the resultant matrix, that is going to be multiplied with A4. Now for these two cases, let's again count the number of scalar multiplication, and the minimum will be put here, okay. So as we did earlier, let's do it fast here. So it will be 0, A3 A4, this problem is already solved, A3 A4 which is 1000, and A2 is 5 cross 20, A3 A4 will be 20 cross 5. So overall it will be 5 into 20 into 5, which is going to be 1500, okay. In this case A2 A3 we already solved, it is 1000. A4 is just a single matrix, no more operations. Now A2 into A3, this dimension is 5 cross 10. A4, this dimension is 10 cross 5. So total number of matrix multiplications, scalar matrix multiplications will be here 5 into 10 into 5, and overall it is going to be 250 plus 1000, which is going to be 1250, okay. Among these two we have to find the minimum one, so 1500 and 1250, the minimum one is 1250. So for A2 into A3 into A4, for this multiplication the minimum number of scalar multiplications will be 1250. So that value is going to be put here, 1250, okay. So now we have solved all the sub problems which will be needed in order to find the final answer which we have to give, which is M1 comma 4. M1 comma 4 is basically what? We have to multiply all the matrices A1 into A2 into A3 into A4, right? So this is already given here, right? A1 into A2 into A3 into A4. This will be M1 comma 4. Here we have to put that value, and let's understand that what is going to be that whatever is the minimum way, we have to find all the ways and we have to find the minimum way, okay. So A1 into A2 into A3 into A4, this we are talking about, okay. So one of the ways can be A1, and then so we are splitting it in terms of the smaller subproblems, isn't it? So this is of length 4. This matrix chain multiplication is length 4. Till length 3 we have, see, length 1, length 2, length 3, all we have solved. So using these subproblems we will try to figure out what is matrix chain multiplication of this, which is length 4. A1 into A2 into A3 into A4. So this is of length length 3, sorry, and this is of length 1. And we already know whatever is the optimum number of scalar multiplications for these two. How? See, A1 is simply one matrix, so 0. A2 till A4, this is basically M2 comma 4. M2 comma 4 is basically already we are having a value 1250, isn't it? So this will be 1250, right? Plus, okay, now let's understand what is going to be the dimension of A1, that is going to be simply 10 comma 5. It is already given 10 comma 5. Now A2 into A3 into A4, see, A2 into A3 into A4 is basically 5 cross 5. The final dimensions will be 5 cross 5. So the resultant matrix, this one, the multiplication of these three matrices, the resultant matrix of this one is multiplied with A1. So these are the two dimensions, and when they will be multiplied, number of scalar multiplications will be 10 into 5 into 5. 10 into 5 into 5, which is 250 plus 1250, which is 1500. Okay, so this is one way. What can be the other way? Other way can be something like this: A1, A2, A3, A4. Okay, A1, A2. We already know M12, M12, which is 1000. Oh, sorry. This is 1000. A3, A4. We already know M3, 4, which is also 1000. Now let's come back to the dimensions of these matrices so that we can find the number of scalar multiplications in order to multiply these two resultant matrices. A1, A2, the resultant matrix will have dimensions 10 cross 20, isn't it? 10 cross 20. A3, A4, A3 is 20 cross 10, A4 is 10 cross 5. The resultant dimension will be of, resultant matrix will be of dimension of 20 cross 5. 20 cross 5. Okay, so overall here it will be 10 into 20 into 5. And overall it is going to be 1000 plus 2000, which is going to be 3000. Okay, this is one way. And the last way will be A1, A2, A3. This is one sub problem, and A4. Now A1 to A3, which is basically here in table, it will be M13. M13. We already know it is 1500 plus 0. A4 is a single matrix plus. So the resultant matrix resultant matrix A1 into A2 into A3. This resultant matrix will be of dimension 10 cross 10, isn't it? 10 cross 10. A4 is basically 10 cross 5. So here number of matrix multiplications, scalar multiplications for this resultant matrix to multiply with A4 is going to be 10 into 10 into 5. 10 into 10 into 5, which is going to be 100 into 5, 500 plus 1500, which is going to be 2000. And among these three values, 2000, 3000 and 1500, the minimum one is 1500. So that is going to be the minimum one. So for the cell M14, which is basically the matrix number of scalar multiplications for A1 into A2 into A3 into A4, that is 1500. Okay, 1500, and that is our answer. 1500, that is our answer.